bot says.
Welcome. Stream starts in 5 minutes.
Gonna teach you something new. Learning and hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow.
T minus 4 minutes.
Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean. Got high expectations, gonna teach you something new. Learning and hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, no knowledge will explode. Welcome to my stream where the fire of knowledge burns bright. Chat with me, let's embark on this journey of delight. From the basics to superpowers, we'll learn and grow. In this stream of knowledge, together we'll grow. Welcome to my stream, where knowledge reigns supreme. Calm and collected, I'm about to go live, you know what I mean.
Stream about to start. 1 minute left.
Gonna teach you something new. Learning and hacking, exploring. There's so much we can do. Feel the excitement as we dive into uncharted lands. New discoveries await in this digital wonderland. Together we'll unravel the secrets, unlock the code. No limits, no boundaries, no knowledge will explode.
welcome in. So, the camera's dead. Well, that's what happens when stream crashes. You tested everything. Let's see. So, first when I started, stream was starting fine, camera and everything, and then I clicked VMware and started the Windows VM, and it totally just, all the screens was black, So, also, I noticed I had Discord on, so two of the things that crashes stuff, well, OBS is very sensitive, and VMware can do that, and also Discord, so... And a few seconds later, I got a phone call, so that's why it was delayed too. While I was talking with her, I noticed, Windows updates, of course, right? It's the update day. So, it's probably a combination of all of it. So now I've restarted, installed the updates, starting to do what the plan was. So, I have Google Gatekeeper track me, and I'm going to go and check what other people have done. And I think that before we looked at some of the notes, and it was like, oh yeah, check this place to find out how you do this. There must be something missing, because what I end up doing is trying to read the code in assembler for an advanced networking program, and I'm not that good. So there must be some other trick to doing it, right? It could also be that my Windows VM it's all updated, It's just turned off certain options, and it might not be good enough. But I don't think that is a problem. I think something is missing from my strategy to try and find this. So we're at the... I'm just remembering. So it is the bad characters. That's what we were trying to find in the memory. Where would they possibly end up? And there was so much other things there, like a lot of 41s and, stuff that I didn't know if it was like old stuff, right? And that's when I'm thinking too, maybe it's randomizing stuff and it ended up in different places, and that's why I can't find it. But whatever. Let's just see what other people did. Now I scrolled far too far in this one. Before I get started, I found some text saying, yeah, it was on actually updating BIOS on actual motherboards physically by connecting to the chip. And then I read something about X99, Chinese X99 motherboards, and I'm like, ooh, I had to Google X99, and I have to see now what on earth my dead motherboard / processor, I don't know which one it is. Maybe it's worth it to find out if my processor is actually good, to buy something cheap. And these are actually not the board. I think the cheapest ones are these. So I think this one had a few reviews that seemed good, but this one has a lot of reviews. So with a lot of images. So there's 662 reviews. And there's also criticism like, this would have been better to do like this. I don't think they're all fake, that's the thing. You could easily make that if you want to sell stuff that doesn't work, so... That's why I'm gonna check on the motherboard now and actually see, before we get started with probably watching YouTube videos. Because in the write-ups, they don't go through all the details, probably, right? They can't skip stuff if they're recording it all, right? So I'm just gonna check here in the box where I have the motherboard. And if you use it, I'm gonna take a picture of Here? No, I think I moved it from before. What's the brush thingy? So that's good. So what's this note? Oh, that's what graphic cards I have in here. It's a GTX 660 580. So got the info. So maybe I should put like one of those cards in this machine. I'm thinking of, oh, maybe I should have put the note back there. So let's see. I have the name of the board. So X99S SLI Plus. I've not removed the CPU coding, so I can't see what it says on the processor right now, but we could just check what is. It's obviously X99, right? This was mostly what I wanted to confirm, but it wasn't just my memory. Do we want? Well, we can accept MSI stuff. So, socket here. This we want to confirm that it's the same socket on this one. So let's say this one looks the best. 2011-3. So it also said something about it not doing one of the complaints, not doing four channel memory. 2011-3, right? This is not what I searched. I searched for X99 only. That's funny. What kit? So this is my search with free shipping and price sort. And this is like memory only or whatever. Some of them are kits where you can decide to, I think this one was like that. You can do with CPU, with RAM. So full computer for 900 Swedish crowns, $90. 16. So we don't want that. We want to check if my CPU works, and if it doesn't, we can order a new one. It seems like kind of cheap, right? But the primary test, though, if I order this, I can also test the other motherboard with another processor, which I wouldn't know if it worked, right? That would be the problem. They know what I want to buy more of. Oh, on an ESP. Oh, no, that's not what I want to buy more of, but I might want to buy it. I think right, okay, fast delivery. Without damage. And a lot of people say that it works good. They have it in their computers. This looks like odd. So the reason I'm looking at these, so let's go for if we do X99, the Swedish word for motherboard, and well, let's check out Amazon too. Amazon is easier if there's problems. Fendic. So these things are horrible. You can't middle click it? No. So ads that you can't click. That's always interesting. So I was just going for prices, right? And we can see the prices. They actually are about 1,000. But these might be like used boards. I don't know. Here. This one. And I'm just gonna check this quickly. So maybe we'll have this as a server. Okay, because this site I'm on this quite a lot to check prices. So this sounds more like a price that when I googled it before, and this is the reason why I think $50 instead of $900 is kind of nice. And those are probably different motherboards, yeah. So what about this? So let's check that one, and that one, and close that one. So this is a motherboard similar to the one I have, which is dead, which is so sad as it's so good. This was my computer before this one, and it just died. Just died on me. I don't know if it was heat or... and it was after I had it open. Maybe I did something static electricity to it. So... Now, what was the name of this? Did you even... Where's the socket? Yeah, there it says. 2011-3. Chipset 699. Yeah. So, this is one of them. Let's see if these have prices at all. Price history. Yeah, so they stopped selling them here. But they were at 6,400. You don't just buy this to test if a processor is okay anymore. It's not like a thing you do. Oh, it went up to 11,000 at the end. That's just some stuff is crazy. But anyway, it's not been sold for almost a year, it seems. So this is an old thing. So if you look at the price history for this one, and we do all of it, yeah, so the price goes up as it becomes less common. So it started 3,000, and then for some reason it's just going up and up and up. So that's just odd. It's not very odd though if Chinese manufacturers make cheap clones of these boards. Oh, these are also tiny. I don't know if you see how tiny they are. There's like RAM slots on the sides here. Then you have like one PCIe and one tiny one PCIe. What is it for? What about this one? It has 8. Well, this is also for 2 processors, right? So this seems to be, as I scroll down in this one, it's also more expensive. I don't want to spend that much. No, right, we're on Amazon now, and Amazon can't do price sorting because it will like kill it. We won't see exactly what we want anymore, will we? Yeah, maybe. So is it worth like $10 to buy from Amazon instead of AliExpress? We would have it here in a few days. Oh, it's still February. There's a month. It's not quicker. This one is quicker. So I'm surprised that the sort here worked. Maybe it's fixed. Never usually works. Ah. So this seems like exactly the same board, right? So I'm sorry for being stuck on this so long.
Potatop says, window shopping or buying?
Yeah, so I have a board. I have the one I googled on. This is what I have. Only it's dead. So I don't know if it was overheating or static electricity. So I checked what they are in Sweden, and they're like 7,000 Swedish crowns, like $700 for a new board, and you don't even know if the processor is fried, you know. But then I read just yesterday. Let's close a few of these things. Yeah, I wasn't actually reading the RAM of these, reading the boot up stuff, you know. And it's mentioned for X99, Chinese X99 is usually low. And I was like, ooh, Chinese. Let's go search on AliExpress. But really, we're going to continue with the Gatekeeper now at just a little time, so I shouldn't dig into this too much. But anyway, these boards, we just found them also on Amazon. So it's like $10 more. So they seem okay. And on Price
I will be
Runner.
hopping into morning meetings in a moment, so we'll be lurking with you in the background. D.
Okay. I hope you have a good meeting. Yes, I'm gonna go and probably watch a few videos on Gatekeeper here. Because there's something missing. Because I don't think I need to be able to do this box. I don't think I need to read all of the assembler for the program, which is an advanced networking program, right? I'm not that good at assembler to be able to read all of that. To be able to find where in memory it saves stuff. Or like where in the program I'm supposed to put a breakpoint to find bad cars. So there's probably some trick I don't have in my notes yet. So thank you for being here, potatoes, and have a great meeting. And I'll not look at this for too long, right? It seems to be like it's the same board from different sellers. Ooh. Oh, well, here's another one, which is also more expensive. And these are sorted on price, so this is funny. So, better board, pricier, obviously, right? But I don't think I will add anything but a GPU, so... And I saw in the images for this one that people had done that. So if you click the more... I don't know if you can see stuff on these images. They're just mostly... One of the reasons I don't like the colors. So, yeah. Let's not dig more into that. I'm just thinking, should I order this now before, you know? If it takes a month for this to arrive, it's not that much money. And I might be able to use my nice processor there. Though it's a motherboard that's the real nice thing. And if it is the processor that's broken, I think it's also like 7,000 Swedish crowns. Yeah. So I don't have a lot of time, as I said, so I need really to get going. I had the stream crash too this morning when I was starting first time. So let's just a quick compare. This is 500, right? And this is 500 to 530. Yeah, so this one, it is also, this is 22nd February. Then we have 13th, 6th, 13, 13, 13, 13, 13, 8, 7. Yes, I'm thinking if I pay more, I get it quicker. So the one with the 6th, it's just a third in price. So let's click this one and see if it seems to be an okay. So SATA. Oh, that's my old motherboard. I'm like, oh. So +3. Oh, so I can do this. Okay. Where's arrow? There must be an arrow. No. Have to move. So this is all the things that come with it. And we can see here, this one seems a bit tight upon the processor. This is my most worry, that if I were to buy this, I couldn't fit a graphics card here, as it's so tight upon everything. Also, I'm thinking of, let's not buy anything right now, right? Let's do a X99 here. And I'm gonna check the motherboard and see if I can see anything, any problems with it. And let's add all of these tabs here and close. Yeah, let's start with actually checking out the board in the microscope, but not today, because now we're going to hop to yeah, I'm going to book my mom's car check too. So this is our goal, doing Gatekeeper. But when I started the VM, I crashed the stream, so I'm not going to do that now. The Windows VM, it's not perfect. So I opened a lot of stuff here. Let's just see if they say what they do this stuff. As it's a very simple thing. I've done it lots of times, but this time it just didn't work, right? So that's why I'm stuck on it. It was also like buggy before. Yeah, so here they have found bad shards. So they're not explaining how they found them. And yeah. Yeah, they recommend this room, and this room I've done, and it's not anything in there that would help. Because what my ways of doing it should be the same. But we can look at the room again. So let's see here. What are these people doing? What do these do? Oh, they're just showing the basics of the box. Here they have the offset. Payload with Amazon Venom. Yeah, so here they just put it in here. Oh, they run Mona. No, I don't want to do Mona. I want to do it myself. Is that how everybody found it? I want to do it manually, you know. So, I've totally not even put this in my notes, I think. Maybe that's the way around. If it's too hard to find them manually, then you hop to Mona. And Mona is ancient, so we would do the x64 DVG version of that. But I don't think I installed even. I don't think I had Mona either. Maybe we'll have to get it. So we got this far, but only after realizing you need to hop 100 characters at a time when you're trying to check for buffer overflow. If you do 10 at a time, or some, I don't know, 20, 15, you will crash at the wrong place and you won't get anything. And that took me some time to find, so I've spent so much time on this box. And also like building my Windows machine for this box, so it's been so annoyingly much time spent. I might actually do like a walkthrough video, which is like planned for this one, as my normal stuff doesn't work. Yeah, so let's go to notes and check. Do I have Mona in there? Yes. Do I have enough about Mona in there to actually get the data? So it's starting on the right screen. Yeah, this is the one I found the information out X99, and then I totally derailed myself. So buffer overflow, and I do have food too. My tummy reminded me. Oh, cool. So if I click once... No, this is up. I thought I closed it back down, but this is this page really where I needed this. So we could hop here to... Oh, this is the first time I use the sidebar. So easy to read like this. So where do I have? Find bad characters. Oh, that was easy to find, right? So all of this focuses on the manual stuff. Do we have any mentions of Mona here? So my brain hopped to thinking about, is this the reason why I heard that they had buffer overflow on OSB and then they removed it? Is it because of these kind of problems where you can get stuck on this detail for a long time? Since it all depends if you're lucky to test with the right number of characters. They're like, now I think I have learned to test different lengths. But I might have forgotten it next time, depending on how long it is, right? So, we could search for Mona too. Yeah, so there's nothing about Mona. So let's find the bad characters here. Yeah, so I've been thinking a lot about pulling these apart, and I think I might do it now because it's a bit too long, you know. You can't scroll even through it, even though we have the side thingy to have different parts. One called basic information, and then we have let's actually make it while I talk. So we're gonna make a new folder here called Buffer Overflow. And in Buffer Overflow, we're gonna put Buffer Overflow. And we're gonna put all the files that belong to it too. This is... I could probably delete this, but whatever. Let's keep it in there. This is also buffer overflow. Buffer test. Processing the port step count. User pass. Oh. I think this might be from I'll ask for a buffer overflow video. And then I still have a start here, buffer overflow. Which now links to this file. Which is kind of good, because I think this is in my file for it. So... here we have Mona. This is probably where I have that data. Mona byte array. Mona compare. Yeah, this is the thing. So... bachelors. So I guess we put Mona in the buffer overflow one. But all the tools are here, so let's not. But this is part of it. What else do we have here? Anything else? Registers. Yeah, so it's all, you know, the basics of... Oh, here's another one that's buffer overflow. This is just an example. What's this? Also for buffer overflow. So I guess we will pull them all up here. So tools we want there, but I didn't like how it was all over the place before. So of course this is also relevant to buffer overflow. More learning. So this is... I didn't check that out. I think I only found the links. I'd stopped writing here. There's more stuff I've done. And latest changes here. Fint. So oopsie. Here we have examples, and it's all buffer overflow, and this one is also an example. So it goes into examples instead. Yeah, this folder was going too big, but it's all connected, you know. And this is obviously I guess it could be for something else too. So It's definitely from a buffer overflow thingy. What is this? Things to think about. An application. Yeah. I guess we put this at the buff too. So before fixing, we have to organize so we can actually see what needs fixing, right? But I want the tools here. Code. Oh. Rewatch later because I didn't understand everything. I don't know what that was. Might have been. Oh, let's see when I wrote that. So 2023-08. That's kinda long ago. Yeah, I kinda thought so. So maybe we should rewatch it now. I didn't know last time. That's so long ago now. So I think it's past 1.5 years now for me to learn this kind of thing. So, the buffer overflow file will now be split into stages, like 0, background information, what we need to know to be able to do it. Background is not a good word, so I'm looking for another one. Like knowledge. Just how info on low level functionality. Well, let's for now, right? And then we're going to do 1. And we get this one in between. Let's make a code here too. Oh, why did I make it that? It was supposed to be a folder. And this will be code.md, so that's why we can have the same name. So let's put all of the code into code. This is so nice to get this a bit organized, because I'm going to go through all of these files and check, because there's definitely duplicate stuff, and yeah, different sources I think these are the ones that are like mine, and this is like Tiberius's Buffer Overflow prep version. And one I think was from Al. Oh my goodness. From last Red's video on Buffer Overflow. Yeah, I'm very hungry. 11 to 5, and I haven't eaten my breakfast yet. So, not that strange. It's all prioritizing, right? Haven't had time yet. So I got this bread fresh from the freezer, and it's like all nice and smells like newly baked. So I haven't eaten this in a bit, so it's been there for a bit. So long since I ate this. Lemon yogurt. And Luba bread. It's good. Can't do a -1. These always look like they're in this for me. I don't like the structure. I think these should be up here. At the same line as arrows. Like the arrows being part of the name of the followers. So, new note. We don't need to have the same as the folder, right? So, practice problems. And we're gonna cut this bit. Actually, just this. Oops. So, we can add more stuff later if we want to. And this is like I'm thinking this shouldn't be 0. This should be like 1 then, or 3. 1 will be what is buffer overflow. We can't have a question mark, which is why I will keep the header, which doesn't have a question mark either. So this will make this so much easier and more readable, and we can see it all when we click on the page, so it's not this infinite scrolling infinitely. And it's hard to update at this stage because you can't find where to update even, and you can't find the information easily. So there, I'm thinking I'll add the add this at the end here of the what is. Like this has actually happened in the real world, and so we have the scale of it too. So how did that happen? Oh, there. Okay. Yeah. Now we can add a question mark there. Then we're just gonna copy this thing instead. Put it here. Why like redo the wheel when you already did it, right? Register memory layout stack frames, program flow in assembler, exploring memory. Might be another point actually. Yeah, I think so. I'll put exploring memory. It's more practical. The other one's knowledge. Yeah, so this goes here. So this is just knowledge. And then we have a practical bit. The exploring memory with more examples, and here we can add more stuff later. So yeah, I've done that before. Come on. So there. And let's make it 4 too. Now we're at the actual buffer overflow. Yeah, let's put this. I'm not gonna do it now. I was thinking maybe I'll do it now. Well, let's put it in this section too. So tips to check out. There. So then we have the buffer overflow, which we might, or which we will, split up. The steps of buffer overflow, maybe? And we will update it. And we will link it to the other documents. Because I don't call this fuzzing parameters. There's actually a step. Step 0, I guess. Is there a buffer overflow, right? Because we need to know that first. And the steps to exploit a buffer overflow. There. And now we have numbers here and we have numbers here. So maybe we shouldn't have numbers here. It's better to just have dots. So, and we'll rename them as we go. Let's make the new nodes. We can actually make more than one. This will be quick, right? We're just copying and pasting. So I guess finding is a better word. Finding a buffer overflow, right? But that could be thought of as being where the buffer overflow is, and that's not what I mean. So maybe there is a better explanation, because so the steps, let's make steps uppercase. I guess we do this one too. And well, we can delete these. And these will be links. So yeah, that's good enough. I don't like the 5 there though. Can I do this? No. Yeah, I thought so. No. So external links. Yeah, do have the parentheses. These internal links, you don't? So if this had been an external link, I could have done like that, and then this, and I could have written clear text here, and let's do something different. And this would be shown for the link. So what about this? Ha! It's almost. It's kind of working, right? No, it doesn't. Nah, it doesn't work. It just hops in there. So let's undo, because it even actually broke the link. It removed the text. Totally bugged out. So the 5 will have to be there if I want the 5 here. And I do want these ordered, and there's no other way to do it that I'm aware of. So the next one to cut out is the fussing. And I don't know why I put this as a lower level. GUI programs, input, test input. When we get a preemptive question, sending more input, then you can help. I guess this is where I need to start. So I'm sorry that I'm not looking at YouTube videos. I was supposed to. This will be soon done, right? GUI programs. You need checking input fields there. Yeah, I see what I did now. I put fuzzing as a sub item of let's see. No, I don't need to switch tabs. but it's really number 6. As fuzzing is not like this on a GUI application, right? Probably. I don't remember how we did that. We did it once, right? Maybe just testing examples. You can't just send command line arguments for that, at least. Or network strings of the network by netcat or anything. Fuzzy. Fuzzy. Whatever. So, these are actually in the is there a buffer overflow? We didn't leave that section. Test input file creation. Check position of saved instruction pointer stack. That's the next step. So this belongs here. Is there a buffer overflow in a UI program? Is there a buffer overflow in input file? So this kind of explains itself, but now we can see that there's stuff missing there. Input files can also be buffer overflows, which it doesn't say explicitly, at least. So, check position of same instruction pointer on stack. Now we're going all stack on this, right? So where is the list? Fuzzing parameters, controlling EIP, identifying bad characters. So, I have to make another one. Oh my god. So, I need to go and make sure my kid eats his food or gets some food. Be right back. Yeah, so he ate a giant half homemade pizza. It's like, what is it, like probably 200 grams of meat on there for breakfast. So he said he'll just make something like a sandwich himself. He doesn't need real food. I'm like, yeah, I get you're still full. That's why we did that before. So I'm gonna rewrite all of these, but not now. That's the way to go to the start of it. This I missed some time before, and then I made it red. Yeah, and this is what I did before to find where in memory to look, and now I couldn't find it anyway. This is where we're at. This is our current problem that we're trying to solve, and to be able to make the notes better, I need to be able to find the notes. So now we're cutting this big document up. So eight, and let's put some space up here, right? I want it to start lower. I'm like, yeah, this is the level I've had before, so there. And just one line. As we put a header under the header. Then we have. So how much else do we have here? Yeah, I was thinking we could just cut this bit out instead and make a new note called 10. There. And then we're gonna rename this one. Where did it go? Did I make it in here? Again. So these angles, I read them as this is the contents of this directory, right? I think these should be in here instead. I guess I could possibly change that with CSS. Right. So, let's do the last bit here. This is supposed to be 9. Using shellcode. I think shellcode is the oddest name for something, but whatever. That's what we will call it. I guess code to get a shell, right? So now we have a more logical structure, and we can focus in on the bit that we're actually having trouble with. And add the part that's not here, which is mono. Right? So this will go up, and then we do manually. Maybe that level? Maybe even level 3. So 2, 3. And then we do with tools. And then we have Mona. And we could just do a link to Mona. But I'm thinking we will copy stuff and then make a link to Mona. So first we're going to fix the steps document to actually link these. So fuzzing there. And I'm gonna replace the names here. So they're the same. And this one, I think I will actually do this because I think both names are okay for now. And this is a bit long for a header too. But we won't do it now, you know? Identifying and finding. I think find is better. So that using shellcode. Let's not put anything there for now. It's not exactly the same as my documents or my thingies. So it can be like this. It's okay. We're gonna focus on what we're supposed to explore, and we have like an hour left. So what we have problems with is finding the bad characters. We are going to explore the option of using Mona. And there's also the if we look at our x64 DBG, we will have a link to ERCXDBG, which is like the same thing. And if we look at that, let's see, is this a link? It's a link to a web page, GitHub. So we don't have a document for it, do we? Install the latest release of get the ear here and put it in here. So last time I started my VM, the stream crashed, but it was doing updates and I had Discord and OBS up. Now we don't have Discord and we're not waiting for updates. Should we try and start it and see if we even have ERC installed? I don't think so. I don't think I put it there. We have x64 DVD installed. No, I think we'll do the theory of it first, but yeah, what should we do with Mona? It will be in the Mona node here, right? So if we go back 2 steps and we make a link for Mona, there, Mona. Ooh, look, pipe. We found out how to do it. So it's a pipe. It's the same as we changed an image size. We also do with pipe. So this is Obsidian information knowledge. We need to put it here as soon as possible so I don't forget to. So linking to other documents. Oh, I actually have a rename link already. Should have looked here. But this is not the only thing I was going to add. What was the other thing? Well, let's update the list. That might have been what I was thinking. We don't need the. I keep looking for steps, and it says second word, and it's annoying. So here, we're going to do pipe. There. Pipe. And it looks very pretty too. Now I'll have to mess with these when I change the names though. So maybe we're like premature in doing this. But there it is. So let's check out the old rooms. I'm sure I was in this already. So now we can see this room. It was long since I did this one. Yeah, the first one it explains it, and then we do the same thing a million times, which is horribly boring. So I don't like using tools when I'm learning things. I want to do it as manually as possible so I really know what happens. And if Mona can find something, we should be able to, right? The Mona script is pre-installed on this machine. I'm sure I have this in the Mona notes, but let's double check. So let's go to the Mona notes. Configuring directory. So all of these notes are probably from this. Not sure, but probably. Create a file in your collie called Buffer Oh, okay. So this was this one. Crash replication. Controlling IP. So I'm looking for the Mona stuff now, but I don't want to miss anything. So here we have Mona. The script will crash. The server again. Listen, command input box at the bottom of the screen. Run the following Mona command. Window should display a log window with the output of the command. If not, click the window menu and then log data to view it. Choose CPU to switch back to the standard view. So I can see this horrible, ugly log window in my head, and how it looks. An immunity debugger is so ugly, and the text is tiny. In this output, you should see a line with stars EIP contains normal pattern. He did that with Mona. Why? It was just so very, very odd. Finding bad characters. Now we're at the place we are, so to speak. But maybe I should put this in my notes too, that you can do this with Mona. It's such a, I'm sorry, stupid thing, but I mean, in all of these you could just see the EIP. Even if you do it with like R2 or something, right? You can just see the EIP. So why run the script to see it? I have to like find MSP distance. $600. Place it in a variable. Okay, so it's to find. They're just running the Python script, and then they're running this. I can't see any other reason they're doing that. That's to see what the EAP is, right? But shouldn't the EAP, when it crashes, if you see the EAP? I don't get why this is done. It's just, should be there, obvious. So, let's go on to the actual thing, right? So, finding bad characters. Generate a byte array using Mona. And execute the null byte. Exclude the null byte by default. Note the location of byte array bin file that is generated. If the working folder set was set per the Mona configuration section of this guide, actually should be okay. So let's put all the things that are the other one Mona things are not relevant, right? So I'm gonna copy the configure directory so that we have a path that we know that we can use in the notes. And then we go here. We can have both of these open at the same time. So Mona. There. So here at the Mona section, we configure directory. Well, ctemp is, everybody has a C if they're on Windows, and this is Windows like only, so this is the tool. It's not like 3.5. That'll be okay. Configure working directory for Mona. So generate a byte array. And then we're gonna copy the command. And I'm thinking this is not necessary either. So note the location of the byte array bin file that is generated. If the working folder was set per the Mona configuration, like it should be C Mona, then the executable, I guess, OCP byte array bin. So I guess it's adding that to the path. Let's remove the comma. Colon, I mean. Now generate a string of bad characters that's identical to the byte array. The following Python script can be used to generate a string of bad chars. Yeah. Should we do his? This is like annoying. I prefer to actually add the string there. No. Add the same. Add the same bytes to your exploit script. So here's all of them. I don't know why it's adding a space here. It's not there really. It's just funny. Yeah. So here's my version. Shorter version. I guess I was having fun of it. Should make it simpler. Just a one and easy to understand. Yeah, this is my current one that I have in my script. So now when we split this out, we're going to talk about what is.
Age says.
Not enough nop lol.
Okay, let's add some more. It's nothing in here though. In the next one we have. I think we have lots of knobs here. So here we have some knobs. Let's make some red text. Add info, what bad chars are. So there's not enough theory here. So add the same bias to your exploit script. So how are you, Age? I was hoping when I stop streaming that you will be streaming some music that I can listen to while I'm waiting for my kid at school. Oh my. Yes, I should finish eating my food because we're leaving soon.
I've been having some crash issues due to a KB update with Windows.
Oh, yeah, me too. When I started stream, it crashed. So, I restart and I got a phone call. 50 minutes later, I started again. I also had Discord on. That's always the OBS crasher. But it crashed when I started my VM, Windows VM, so then it just died. So I think I was streaming for like 1.5 minutes before it crashed. So it's do you have problems continuously, not just from it needing to restart, or? So that we can ask. It's not good to read stuff not at the same place that you're actually typing. So I was like, oh, did I type ask or not?
I'm gonna have to try to fresh install my video drivers or roll back. Both monitors go black and at hard HRK grooks.
Okay, yeah, so when my stream crashes, it's all going black. All screens go black. But that's kind of like a common thing. It often happens when... Also, if I have too many YouTubes and Twitch streams on at the same time, they can all, like, crash. But not that black screen thing. So I have some issues too. But I'm gonna, like, reinstall everything too. So I'm thinking... maybe I'll just get a new computer first. I should add it to my stream, or rather learn how to do it, like... I want contributions for a new computer parts. I should add that. I should learn how to do that. Add the same bytes to your export script so that we can ask Mona to compare. So, so I know why this isn't a good way to do it and why I didn't want it, because it will be not perfect, right? That's why I want to do this manually, but I couldn't this time. That's why we're making these notes. My manual approach failed. And the first one I looked at, no, that one didn't have anything. Here, they were using Mona. Am I, like, blind? I used Mona. No? Why are we so late in the file? I guess I'm like... maybe I saw something in this one that I didn't like, so I hopped to the next one. No, I don't think we opened that. Here it is. This is what I saw, the Mona outfit. That's why we're making these notes.
It's giving me an app model runtime error for non-immersive package error in my event viewer.
I've never seen one of those, so I'm sorry, I can't help. I didn't actually check mine out since they solved themselves, you know.
Just something to watch for.
Yeah. So I hope you solve the problems by a new driver or something there. So I usually just look at the event viewer if I can't solve a thing, and I don't think it's happened in a while. I really should, though, I guess, when OBS crashes, to see what is really the problem. I know that when I installed, maybe not even the latest version of OBS, it stole the what's it called? The camera thingy that you can use for meetings. That thing, it just removed it. So something obviously went wrong in my upgrade. And I haven't added it back. I should do that too. So you know when you're like, oh, I need to stream now, I can't look at stuff and explore what happened to it. Just have to work.
Yeah, I get you.
So, let's just continue reading. We imagine we generated this, not their way. Exploit PyScript, set the payload variables as string of byte characters. Then start with PXE, and run the modified exploit Py again. Make a note of the address to which the ESP register points, and use it in the following Mona command. So, here we have a problem. They assume a crash, right? Because they have a controlled example. And mine wouldn't crash here. Not the right place, at least. I think they're assuming a crash. If it's just running, why would you want the ESP register? As mine is a network program, it would be waiting for a... mine is obviously gatekeeper. That's up all over the place here. Let's just run it. Only I need to start that VM that crashed my machine then. So let's make notes. Rerun. I'm making general notes, Rerun the exploit. Well, after trying to be explicit, after restarting the program. Oh gosh, wrong place in the keyboard. So, do you have any tips, Sage? So my problem is that when I do my manual thing here, and go in and look in memory and try to find this, I even try and find the place in memory where it's put by just putting 41s in there, right? Or A's. And I can't find it because I need to put a breakpoint. My little here, observe, we need a break program execution with a breakpoint. And I don't have a good place to break it on. It's a long, big program. I can't read all the assembler code. It's too complex. It's networking and stuff, Yeah. And we can use an aid. So, I've added these notes to the tricks. We look at memory. Maybe it's easier to do this with GDB that's here. Now I've been doing x64 DBG instead. Yeah, maybe I should go this way. Why did I go GUI on this thing? It's not always easier to find something when it's possibly too much information. And all I want to know is to look at the memory. And if memory is in the graphical one, you can't just set any address and look at it, right? I can in R2 or GDB. I don't know why I have GDB here, but the example was that I would do R2. Yeah.
Rose did a wonderful write-up that might be helpful. Web link.
Mm. So um was there anything about buffer overflow in here? Did I miss it? Recon, web stuff. FTP. Backup zip. Zip to yarn. Unzip. And it's a PHP and CSS file. Might be off here. With the wrong one. Definitely rock you in there. There's nothing of buffer overflow in here. So if I click something else, and click this one again. Oh, now we're at a different page. That's better. That was interesting. Very interesting. So it's the same URL, right? Oh well. No, nothing about bad cars in here. That's a bit mom. So I could just skip that step and just test something, but she's skipping the bad car steps. Well, let's see. Is he using a? Let's see. Payload. I like the colors, by the way. I'm just not finding what I want. So she had links to where she got this, right? So maybe there. I'll just see once more if I can see her. Is she using... What shellcode is she using? I'm mostly confused by not finding stuff I'm assuming should be here. She might have already had it saved in her Python file. Oh, here. Shellcraft, AMD64 Linux SH. Yeah. I need to check the poem thingy. It's on my to-do list. So maybe that's what we should do, really. Right. It's kind of high up on my to-do list, even. Oh. Example curriculum. Okay, so... Okay, the link doesn't work for me because I need to log in first. That's it. Well, why not make a login then? Right? Because I don't have a login, I think. No. So let's go back. So this is free. So click enroll. There. Yeah. Sign the code. Right, sorry, you were not looking at the right screen. That's bad. I'll just click the link there. Just the password for my mail. So let's see. Will we get an email? I'm just looking at all my spam. It's not that bad. Do we have a code? So we got to the right one. So we want to see bad characters. So, how do I get to more stuff? This was not what I want. Can I search somehow? So we want buffer overflow. Nothing. Okay. Yeah, so sorry, but that didn't get anywhere. She skipped the bad car step, which is might be in the Pwn library there somewhere. If it's, I don't know it yet. But let's read the exploit script here. So offset. There's no bad characters anywhere. She's just running the shellcode. So what if the shellcode contains stuff that can't be sent, can't be read by the program? That's where we're at. Sorry that it doesn't seem to. Now I've seen that this exists, which is very interesting. So we need to explore this. I'm assuming there's no way that this could. I mean, to find the bad guys, we'll need to restart the program and stuff, so one thing can't do it, you know? And this seems like something that will just give us shellcode, right? So, solving a simple buffer overflow with controls. So the reason why this one is a bit of a mess for me is that it's such a big program, right? I can't read all the assembler. It's too big. If it's a simple program, you know, like this. So I imagine this code is huge, complicated. So, but it's still the same thing with the bad characters. If, let's say that I guess that this function probably removes all of the common ones, right? And it could do that by just coding it somehow. So it's not like really limiting in that way. Yeah. So what I want to know now is that ASM function. Swapping out the shellcode and tidying things up a bit. Yeah, I'm going back to GDB and R2. That's probably the right thing to do. Live overflows video. Okay, where's that referenced? Here. So we can check that out. So I have like 25 more minutes. But this is what I plan to do, like just read stuff and probably watch a YouTube video, but I haven't yet. So I resigned to having to do that for this one, because there's something missing in the way I do stuff. Because of this big, huge program, if you get one of those, it's tough to find the right place in the memory where the characters are. So maybe I should make a string. I don't know how to search in memory. That's probably what I need to learn. If I in x64dbg could search in memory, then I would have solved it already. So why don't I learn how to do that? That's one thing to do. Let's put it on a post-it. Also, can we do this in R2 and GDB? search for memory contents. I only know how to look at memory at a specific address. And that I only know in R2 and GDB, not in x64. I'm just scrolling and like, oh, this is a GUI. How do I do this? I'm much more comfortable with the command line. So did I get yogurt on my hair? No. So very simple program. I didn't even read it. I'm looking for the bad cars. No. So here, they're doing bad cars. The contents are checked to see if they contain any bad characters. Oh. Yeah, this is not that kind of bad characters. And it's the only mention of it. Yeah, I love the face. What's up? Program receives signals again. Yeah. Terminated with the program no longer. Will I get annoyed at this too?
So
that it's not enough information.
That can happen during exploit development, and I promise you I will share a full exploit development walkthrough of this small example challenge today. So grab this code from the link below, and then use GCC to compile it in this way. And yeah, I guess it's a dangerous function, you shouldn't use it ever. To develop this exploit, it would be fun to have it more look like a real challenge. So I'm using Socket here, which you can install with apt-get.
Sorry for the speed.
TCP socket and listen on port 1337. The other settings are not that important, but you specify an exec, so something that it will execute when somebody connects to that port. Then I'm using std buffs to disable the buffering of the in and outputs of that program. Otherwise, you wouldn't see like the input and output. Doesn't really matter. And then we execute the binary. This means we can use netget now to connect to this port. Oh, and I guess I accidentally entered a capital A, so I've been blocked and was reported to authorities. So obviously broke now. But if you don't enter a capital A, the application works and you can enter another input. So just a quick reminder from yesterday's video, there is the buffer overflow caused by the gets, which writes data in this limited buffer. But we also have a format string vulnerability here. We can test for format strings by basically entering format characters and see that whenever this data is used and outputted, printed again if it contains weird numbers. So for example, if I'm using %p to basically print the address of something, you can already see, yeah, that output was not simply reflected back. Those %p suddenly became addresses and numbers. And in main, we have a loop around this vulnerable code. So this means in the first loop, we can use the format vulnerability to leak values or addresses from the stack, which we can then use to defeat ASLR. Basically, we just leak some addresses and then we know where the stuff is in memory. And in the second loop iteration, we then can trigger the buffer overflow, now knowing where our stack is. Now the exploit I'm developing here is pretty lame. But if you are interested in how actual good people are developing exploits and you like to watch that, I really highly recommend to you Zeta2's YouTube channel or Carlos Benson. He's organizing so-called pony races. This is a live event where 4 people basically race for an exploitation challenge. And you can watch them simultaneously, and Zeta2, together with his colleague, is commenting this whole thing. So it's really, really fascinating to see the approaches they take and who gets further, faster, who finds the bug first, and all that kind of stuff. It's really, really interesting and obviously also fun. And recently Zeta2 also asked, how do you name your exploit scripts? And then people were saying things like solve.py or x.py, amateurs. So I suggested the superior asd.py, or sometimes even asd1.py, asd2.py, or asd.py, depending on how many exploits you're writing in the day. So here's my asd.py exploit script that we will be using now. So let's create a socket and connect to localhost. So let's also install the Python extension for Visual Studio Code. So our code connects to the server localhost and then attempts to receive up to 1024 bytes. So it prints the welcome text. So you know already that we can leak some addresses with %p. But the question is, what actually did we leak here? Where does this point to? So there are basically 2 things you want to do now. First is a quick idea what the address is, and then you want to know exactly where it points to. So then we want to find the process ID of our process. Now these processes here are related to Socket. This is the actual binary that is running. So this is our PID. Just keep in mind we executed Socket with root, so this process runs as root. So that's why we need sudo if you want to access the file system of this process. And specifically we want to access maps to get the memory map. Now the first address that we leak is in 7ff75. So let me just copy this here over there. So now we have it here at the bottom. So the first address here. Now the first address is pointing to libc. So if you would want to leak an address of libc, so basically defeat ASLR of libc, so you know where it is memory, then the first address you could use that. But we look for a stack address. So the next value here is 7ffe4. So yeah, the next address lays between this start and end address. So yes, this address here is from the stack. Now that we know the process ID, we can also attach GDB to it, and then we can specifically look at that address. So I'm examining 16gx. G stands for giant, I believe. That's the output format for 64-bit, and then we want it in hex. Okay, so there is no value there at all. We can also print a bit more, but we don't find anything recognizable. So it points somewhere on the stack. It definitely helps you to basically defeat ASLR, and you will be able to find where the stack is in memory, but it is like not a super convenient value. It doesn't seem to point to anything useful for us. So this address has a certain meaning, and we want to figure out what that meaning is. Now it could be a good idea to always look at these things in a certain context. So we attach to this program now at some point in time after we have done some input or so, and we could now investigate the memory. But memory changes during the execution of the program. So it makes sense to think about the context you want to be in when you are investigating the memory. And so generally a good idea is to kind of look at the state of the memory and the state of the stack and all that stuff doing your investigation at very critical points in time. And this could, for example, be at the return before the buffer overflow. Basically, you want to know how does the memory look like before I get to my shellcode, or it could, for example, be just before or after triggering the format string vulnerability, because there maybe these values have meaning. So let's set the breakpoint at one of them. I guess we can set the breakpoint at the return where we could trigger the buffer overflow, just because we need that later anyway. So here, this is sample main. So here we see the vulnerable printf. We could break here, or we could break at the return. It's not like there's much happening after this printf and that return, but it's still important that this is kind of the context we want to look at those values. So let's set the breakpoint at the return. Now we enter again our leak. Now this is also kind of interesting. We could quickly compare. Oh yeah, the values are still the same. So we know there are no weird side effects or so. And so now we hit the return. Let's investigate where this address points to. So now looking at this memory, there's all zeros. I know there's some random data down here. I'm not quite sure where it points to, but we also know that we should have data on the stack because of the buffer overflow. And I don't see this data here yet, but it's also difficult to see our data. So maybe let's add a couple of recognizable characters to our input. So let's continue. Let's do like xxx. Then we leak our output and a couple of y's. Interesting. See, now the second value changed. And look here. These are our x. So it leaked our x's here. So you can see that the length of the input seems to influence what some of these values are. So let's check out where it points out to. We still can't see here anything, but maybe let's go a little bit back up and see what was before it. And look at that. And look at that. We see our input. These are our y's. And look where the 2, 3b is. So this address that we are leaking seems to point at the end of our input. So let's test our theory. So let's use 3% p with a comma separated. So that should be 1, 2, 3, 4, 5, 6, 7, 8 characters. Now this leaked address should point at the end of that input string. So again, this address is just 0, but now let's go back 8 bytes. And here it is. If you actually print this as a string, examine string, you can see that it indeed points at almost at the start. I forgot the null byte at the end. So actually, we have to subtract 9. And 9 is the start of our string. So now we can use this string as a leak and subtract 9 from it to find the start. So we send an input, and don't forget the new line. We need to send, that we press enter, the new line, and then we try to receive the response. Just FYI, sometimes the receive is too fast here, and the server didn't actually send you the output yet. In these kind of cases, you just need to build a loop and basically program yourself a little read until, so you keep receiving until you receive what you need. So try it out.
Cool.
There we go. We get our leak output, and we get asked to enter the next payload. So let's extract that value here. By the way, I'm using here Python 2 just because doing this kind of exploit development is a little bit nicer in Python 2. Python 3 is a little bit annoying with the byte ASCII string conversion stuff. So we can split the response at the commas. Oh, see here, I executed it once, and we didn't read fast enough, and on the second try, it worked.
Yes, I don't want to watch YouTube full stream. So I only have a few minutes left, So we have like 20. I can continue watching. I feel like I think that it was still too slow speed, so, and I think I can't stream that speed really, right? So let's look at one of these that are actually the things. What they are doing exactly. This is where I was starting really. So if we go through here and see how far have they gotten at this stage. Oh. So we kind of got exactly right. They're using Mona. So, yeah. So this is what I was just typing in my notes. So let's pause that one. This one, what are they using?
Hello. In this video, we're going to work on Gatekeeper.
Someone talking at least.
Is part of the offensive pen testing
Oh,
learning path
my
on
God.
TryHackMe, and yeah, it is part.
I can't handle that speed. It's I would do the same speed. It's not that. It's just that my stream is ending soon. There, finding bad cars. So.
Send is signed P, so basically create a working folder for every time you run a Unity debugger or try to debug a binary, and it's basically going to name the folder to the exe name. So if you've done this the first time ever, make sure you copy this line first thing first.
God,
once you
I
launch
can't
the
see a thing.
debugger. Already done that, I forgot to tell you that actually. So make sure you follow every step on the Buffer Overflow prep to tell you basically everything. So once we have the working folder set up, we should create the byte array, the Mona byte array type B, /x00 in quotation mark, and it should generate this default
This
byte
is
array.txt.
exactly what we put in the notes.
The C folder, Mona, gatekeeper, and it should store in here. This is where it's stored at. You see here, the argument is byte array type B, x00. That's all we want to see. So this is the default byte array we want to look at. And next up, we want to use the Python 3 byte array.py. This is the same default byte array, x00. Want to go to exploit.py. Let me move that actually. Let me move that forward. So you could copy the byte array.py result onto the payload and put it in quotation mark and in parentheses on both.
It is good to have seen it done. I
did
did it long ago. Then it was like
4138, but it doesn't say like 41, it should say 41, 41, 41. We want to test that. It seems like the offset is correct, but it still has some sort of buffer going on. But I want to check this real quick. So it's not that big of a deal. I think the exploit should run normally. So save this. So this is all we need, the IP. Also the offset, we want to type 146 into our offset because we found the offset on this. And offset, return number, return section to BBB. I skipped one step with this. We could do this 2 times actually, but we'll do everything at once. You have payload. So the byte array we generated, save that, and we're going to go to the exploit.py. Make sure we restart the program, run it with the red play button, and run the exploit.py again. And you can see the IP on this seems like it changed the way we wanted to change. It's going to 42, 42, 42, and it's basically mean BBB in hex, I think. And the ESP on this is B819E3. So we basically going on to the next step of the Buffer Overflow rep. We can basically compare this to look at the bad character. Let's see here. Make sure we want to verify. So okay, so it is gatekeeper, the same way it's spelled on this. Oops, 2 exclamation point. So the way we compare this is to type exclamation point Mona, compare type F for the folder or the file, and then it's stored at C Mona gatekeeper. So the name of the executable we're testing, and byte array.bin, and we want to type out the ESP.
Yeah, so crashing it with a crash at the same time.
A bit of problem. So I'll copy this to my note here, and we find the possible batch character. It's say 0008. So it could be the byte.
Maybe that's the thing I should do.
Just to give you a little bit of spoiler here, if you see something like this, like a really small amount of bad character, like 2 or 3 bad character, it should be the right bad character we want to look at. So the mayor, the room creator, kept it simple. If you see something like this, like around 9 bytes, or not the 9 bytes, but like if you see the 0008, if you see something smaller than say 5 characters, if you see more than 5 characters, it should be you should do the find bad character twice, 2 times, or 3 times. But if you see something like this, that should be our bad character we want to look at. So let's save that. I don't want to go any further, but I want to test though. I want to check if it works. So if you see 0008, or you see something small as this one under 6 or 5 characters, this should be the bad character we want to look at, the bad char we want to look at. So we can try to generate a venom with this and change it to the IP I'm currently using.
So
so
he's repeating stuff too. I'm sorry. I'm just hurrying. And so I'm thinking. So the data we send has to be approximately 200 characters, and our bad data string is bigger than that. It says 255-ish if we remove null. Yeah, so maybe I should just play around with it myself instead of doing this. And try and make it actually 200 characters. If I send 200 characters, then it should crash. So then it will be a different thing than what I was doing. So if we look at I just close my mail down again. So what I have in mind is generate characters, and I have the remove the bad characters we found and like run it again, you know. When I run it until I don't have any more. But in the script, I think I probably have. Let's see how far along this one is. Yeah, so there's that code. So yeah, we have bees in the written paddings. This is yeah, this is for another one, username. So right now we have a connection outside. No, it's inside. We don't have a loop in this. That's why. The fuzzer has a loop. So I don't know. I think I might have updated this one. I don't want to start a Windows machine where I have the latest. That's why we're looking at this. Yeah, so this is probably my latest, because I have added, if you get bad crashes with one step size, try bigger and smaller sizes. So I had 10 here, because when I tested manually, it crashed at like 14, right? So I didn't add a lot of characters. And apparently, you get the wrong crash. So you have to put 100 at the start, and then 200, and then you get the right crash at 200. So, and I think it's probably in here now. Do I have the variable for 146? Yeah. So 146 is the correct number, so it's in there already. So, but in this one, yeah, so I made a function to be able to handle over 5,000 characters, because I didn't get it to crash at all. So I went crazy with it and sent it thousands and thousands of characters. Maybe that was another program. Yeah, I think it was another program. I don't remember anymore. So, yeah, now I remember. I didn't send the right line break character, so that's why I got so high. That's what it was. So if we have a comment here somewhere, add if can't receive data, and I noticed this in another one. Yeah, if can't receive, because the other one couldn't receive. And I had pauses here to debug. Yeah. Because we're receiving data here, because it sends data back every time. Yeah, I'm remembering it now. So it says hello, your text, 3 exclamation marks. That's what it sends back. And that gets corrupted already at not a lot of, definitely less than 50 characters, right? So it starts sending back a few junk characters. And we have this in the notes. on this box. So I have my old notes and we made new notes. Last stream I did this. Here's my last. Yeah, I didn't make any notes on that. So here's the first test for this one. And we got a file from SMB. And then we had here. We're sending lots of data. And we're at 105,000 characters there when it says receive buff exhausted. And this was because I didn't send a new line there. Or a full thing. So that's when I added this comment. It grows, you know. Then we had... Then I tested it again manually here. Here we're not a lot of characters and we get these odd characters sent back. And then it took dice on us. And I got the same thing when I tested here. Doing it again. This crashes it. This is not 200 characters, right? It doesn't crash from 100 characters though, but it crashes from this. So your first thought is not to start with 100 characters, right? And then I tested a lot to reconnect here to see how long it took for it to become online again. And there it's online, it replies okay to several messages. And then we're like on 10. $150. Yeah, we know it's 146, right? So this would have been a correct crash, this one. Yeah. So yeah, so this is the correct one. So we don't need to do anything to see the EIP. I don't know this odd thing. We're running Mona to get it. It's just odd. Yeah, and this is what I've been reading for hours. So the funny thing with this is that it counts how long you've been running it. And it says time wasted debugging or something. And I think it's on 7 hours or 8 hours though, probably. That's embarrassing. Trying to read assembler code and find a good place to put it. This, you can see this is a breakpoint here. So this was what we were trying last time. And we failed to find the data for the bad cars. So this is where we're at in this one now. But I'm not even starting it, you know, because we need to find a new way to test this. And maybe I have a few thoughts, like not sending the full characters, but actually sending like 147 characters. I don't know, 150 characters. Ish. Not sending 250. Maybe it breaks it. So as it is enough for it to crash, we should be able to see it in memory, right? But I think the 200 made it crash and we could see it. So here, That's exactly what we did. We don't have the output. Yeah, we do. We send 100, send 100 and 200. And the 200 made it crash. This is actual program, Gatekeeper EXE, which is started with this X32 DVD. It's a 32-bit program, as you can see. On the length of the addresses and such. Registers. IP. So if I send 200 characters and not 255, I don't think 255 made it crash. Did it? Yeah, so it might simply be that there's a bug. There's a difference. I shouldn't call it a bug. In my fusser and my exploit. Right? That might be the difference. And the current files I'm using, they're not there. So maybe we should just run the fusser with the string instead. Just put them in here as a debug. Maybe that's all I need to do. And I guess we can use Mona or the X32 DVD alternative to actually find the string in memory. But I need to learn, as I put in my notes, notepad, learn how to search in memory in these tools too, right? And again, was I not showing you what I was doing? So what we've done so far on this box.
New follower Nelson 403. Less than 3.
Welcome in and thank you for the follow. So first we did an nmap, and we found this fun part here too. We also found SMB. We checked SMB out, and we downloaded the file called Gatekeeper, and we tested it here. We run the fuzzing script. This is 5,000 characters just to be able to do like infinite amounts of characters. With the help of this function, you just tell it what string length you want, and it's put random, like ace, I think. Yeah, ace. And then it ends with these non-repetitive strings, so we can just add the 5,000 times, whatever, you know. Yeah. And here's the output from the script running, and here's the program we're running on our Windows machine. And we can see the crash here with the EIP. So it is sending 100 bytes, sending this, receiving it with hello, and exclamation mark, and it never replies on 200. It crashes. So if we send 200 characters in the same way that we send it here, we should be good. Really. So I guess I got a bit stuck on the finding a breakpoint stage, I guess. If we can crash it with such a tiny string as 255 characters, well, 146, right? Then it's good enough. So maybe I didn't even have to research this like this. Maybe I just had to rewrite my own script and think a bit. I've learned a lot though from reading all this assembler This is an like backup alternative too. I haven't changed these notes, but I was going to add this to. Yeah, I added the header here. To our new nicely sorted Buffer Overflow notes. So today we cut up this long document that contained all of this into stages, so we can more easily find stuff. And this was steps, will also contain links to all of them later. So, yeah, this with the break program. This is a bit what I got stuck on then. I guess that all other programs I've done, they've been like been able to handle more data, maybe. Well, at least bigger programs. I don't know. We have a next step to do. Let's put it up here. Next step. Just send 200 bytes. Right, I know why this doesn't work. It's because if it's terminated by a bad character, we don't know what bad character it is because it's not overflowing. That's why it doesn't work. That's why we need the breakpoint. And I should add that to the notes while I'm at it. Before we stop streaming. So, there. So, yeah, right, it was already up. Oh, wrong one. So, the reason is that the buffer will not overflow if the string is cut short by a bad character. So that's the whole point of it. Right? That's why we need to add a breakpoint. And we won't end up at the same place. Maybe we will, kinda. So we can go back, we can step back. So this is a bad one. Try stepping back after the fuzzer crash and see where we are in the answer and put a breakpoint there. Because the EIP is off, it's in Tracy land. That's what we want it to be. It's overridden, so we need to step back before it's jumping to the bad address. And then we can see where we actually were. Oh, that's probably what that's a step I was missing. I think that's the step I was missing. I think you can step back. That would be nice to be able to step back. Just run it to crash, step back, and if it works, it works, But I need to drive my kid to school now. So let's raid someone. Maybe I'll continue afterwards. Oh, looky. So, are we gonna raid? We're gonna raid Theo. So. And I'm not in the raid, oh my god, I need to hop into my own stream. I have to join the raid.
PV says,
Thanks for the stream.
Oh, thank you. It was a very odd, messy stream. I'm sorry about the messiness. Yeah, so next time we will see if it works. To step back. Oh my god, I still have breakpoints misspelled. There, now it's fixed. Breakpoint. Yeah, so let's see. It's just halfway. I'm gonna click because I need to run, really. Say hi to Theo from me. Thank you. Bye-bye. Have a great day.
Hey, Fix It. Thank you for the raid this morning. How you doing, Fix It?